Okay, 6.6, finding the vertex of a quadratic function. Remember, right now we're looking at the equation in vertex form. Remember, the general formula is y equals x minus h squared plus k. Now it's asking us to find the vertex of the graph. So first thing we need to know, vertex is h comma k. So whatever our h value is and k value is. Then max or min, that is the y value of the vertex. The horizontal asymptote, or your asymptote, it's the x value of the vertex. So the horizontal asymptote is basically an imaginary line. That splits the parabola in two. So when we look at our equation here, I'm not looking at the negative 2.1. That is actually your a value, because there is an a in this instance. Here's where I'm looking for my value. This, you're taking your equation. X plus 31 set equal to 0, so x is equal to negative 31, where remember h is equal to x. That's where the h is at. The k value, which is the y component, is your 34. So your vertex is negative 31, 34. In example 2, they didn't give us our equation in the quadratic form. They gave it to you in standard form. Standard form is ax squared plus bx plus c. So in order to find the vertex when it's given to you in this format, there's the vertex formula, which says x is equal to negative b over 2a for the x value. Then use solution of x, plug back in original to find the y value. So we're going to take our equation here. So we have f of x equals x squared minus 4x minus 12. Identify your parts. The a value is a 1, the b value is a negative 4, c value, which we don't really need, is negative 12. The equation is x equals negative b over 2a. So x equals negative b over 2a. Use substitution. Negative of negative 4 over 2 times a 1. 4 divided by 2 is a 2. So I know that the x component is a 2. To find the y component, take your function equation, f of x, which is the same thing as y, x squared minus 4x minus 12. Substitute in 2 for your x values. 2 squared minus 4 times 2 minus 12. Order of operation, GEMDAS, exponents need to be done first, so I become 4. Then your multiplication, which is negative 8 minus 12. Add left to right. So 4 minus 8 is negative 4 minus 12. We get negative 16. So our vertex is 2, negative 16 for this problem. Okay, on this one it says f of x equals 3x squared minus 6x minus 72. So again, we're going to use x equals negative b over 2a. So the a value is a 3, b is a negative 6, and c, which we don't use for the formula, is negative 72. We're plugging it in, so we get negative of negative 6 divided by 2 times 3. Positive 6 divided by 6, I get an x value of 1. So we know that the x value of our vertex is a 1. Take your original equation, which is f of x, is the same thing as y. 3x squared minus 6x minus 72. And we're going to substitute the value of 1 in for your x values. So 3 times 1 squared minus 6 times a 1 minus 72. Do not multiply 3 times a 1 first. It's 1 squared, because remember, this could be a different value. So 1 squared is still 1. Negative 6 and positive 1 is negative 6 minus 72. So we have 3 minus 6 minus 72. 3 minus 6 is negative 3. I'm short $3 and spent another 72 we didn't have, or negative 75. So your vertex is 1, negative 75. The next example says we're given f of x equals 2x squared minus 6x minus 20. It says determine the following. Enter all numerical values as integers, fractions, or decimals. The smallest x-intercept, the largest x-intercept, the y-intercept, the vertex, and the line of symmetry, which is also known as your vertex form, the x equation. So first thing, taking our original equation. Define your x-intercepts. First thing we're doing, we're solving this to find our x's. I'm going to set it equal to 0. And notice at first they're all even numbers. So I am not dividing by 2. I'm just factoring out the 2. So 2 comes out. I get a 0, value 1. 6 divided by 2 is a 3. 20 divided by 2 is a 10. So we're at this instance. Now, numbers that multiply to 10 to add to negative 3. Well, the only numbers that we have are 5 and 2. That gives you a 10. Now, to give us a negative 3 when they add together, the 5 has to be negative, the 2 has to be positive. So here are our x-intercepts. So opposite of the sign inside. So x is equal to a 5. X is equal to negative 2. But you're not writing the x component. And that normally you would list these as ordered pairs. So this is actually 5, 0, and this is negative 2, 0. But for this problem set, it just wants the x value. So x equivalent to, now it says the smallest. Remember, the negative 2 is smaller. So I'm going to write negative 2 first, then the positive 5. Now to find the y-intercept, we're going back to the original equation. To find your y-intercept, remember, y-intercept, you make x equal to 0. So 2 times 0 squared minus 6 times 0 minus 20. Well, anything times 0 cancels, and anything times 0 cancels. You're left with negative 20. So normally we are 0, negative 20 as an ordered pair, but they just want the y component value, so negative 20 is our answer. Define the vertex. The vertex equation. Your answer is going to be between the 5 and the negative 2. So the easiest way to do it is use your x equal to negative b over 2a from the original problem. We know that a in the original was a 2, b was a negative 6, and c was a negative 20. So we are negative of negative 6 over 2 times a2. 6 over 4, which reduces to 3/2. In this instance, we're a fraction. So the x value of the vertex is 3/2. To find the y value of the vertex, take your original. And now we're plugging in 3/2 into it. Yes, so this is a very ugly fraction because we're using fractions in this sense. You need to square the problem first. So 2 times 3 squared is a 9. 2 squared is a 4. 6 times 3 is 18 over 2 minus 20. 2 can go into the 4 twice. So I see 9/2 minus 18/2 minus, I'm going to write 20 over 1 because we have fractions here. Since the denominators are 2's here, I need to make this a value of 2. So I have 9 halves minus 18 halves minus, to get a 2 here, I'm multiplying top and bottom by 2. I get 40 over 2. Now all 3 pieces have fractions. Now we're going to do our math. 9 minus 8, I'm looking at the numerator values only. 9 minus 18 is negative 9 minus 40 all over 2, so negative 49 over 2. Negative 49 over 2 as our y value of the vertex. The line of symmetry, that's the equation that's x equals. This is where our line of symmetry, it's the same formula for the vertex. So our line of symmetry is 3 halves. Our next problem. So it's one of our launching problems. So it says NASA launches a rocket at a time value of 0 seconds. Its height in meters above sea level as a function of time, and they gave us an equation. So this is a given equation. You don't create these. It says, assuming that the rocket will splash down into the ocean, at what time does a splashdown occur? So the rocket splashes down after how many seconds? Then it asks you, how high above sea level does the rocket get at its peak? The rocket peaks at something value over sea level. So first thing, we have our equation. So they want to know as after how many seconds, at t seconds we launch, t0 we launch it. And they want to know at what time it's going to go, the rocket's going to go up and then come back down. So they want to know the end value of time. So we know we started at t equal to 0 and they want to know what time did it end. So in order to do that, we're solving this thing for t right here, this equation. So you're taking your equation, set it equal to 0. Negative 4.9 t squared plus 52t plus 318. Now, we need to see if 4.9 can go into 318 easily and 52. So 52 divided by 4.9, 10.6. So the easiest way to do these is using the graphing calculator in the equation. So you're going to go to treat this as the t's as an x. So we're going to go to the y equals, clear your equations. Okay, so we're going to use the graphing calculator. We're going to plug in, instead of the t, you're going to use the value of x. So we're going to do negative 4.9 x squared plus 52x plus 318. Hit graph, and yes, your graph is going to be very not in the screen, but we're not looking at the graph. We want to go to the table. So you're going to go second and hit the word graph to give you your table values. And so normally you'll start out with the 1 here, x equal to 1. And all you're going to do is you're going to arrow down until the y value approaches 0. So right here between 14 and 15, 14 and 15 seconds is when the rocket's going to launch back down. But to be an exact value, because it's not going to give you an exact value here, we're going to use the quadratic formula. So I did this instance with the graphing calculator to see how close we are. So remember, quadratic formula is what's going to play into this one to give us an exact answer. So remember, x equals negative b plus and minus radical b squared minus 4ac all over 2a. We already know that negative 4.9 is our a, 52 is the b, 318 is our c. And we're going to plug it into the into the equation to see if we can get an exact time frame. So negative 52 plus minus 52 squared minus 4 times negative 4.9 times 318 all over 2 times negative 4.9. So negative 52 plus minus 52 squared is 2704. Negative 4 times negative 4.9 times 318 is positive 6,232.8. 2 times negative 4.9 is negative 9.8. So now we're going to do the math inside here. Negative 52 first, plus and minus. 2704 plus 6232.8. And I'm just going to go ahead. So that gives us 8,936.8 over negative 9.8. Now, remember, it's negative here. If I add the answer of the second square root, I get negative 52 plus 94.53 over negative 9.8 and negative 52 minus 94.53 over negative 9.8. The reason I'm showing you the breakdown is if I add, I'm short negative $52 and add 94, I become positive, but divide by negative, I'm negative time, which we can't have. If I'm negative and subtract 94, I'm negative, and divide by negative, I become positive. So this is the one I'm keeping. So negative 52 minus 94.53. Enter and divide that by negative 9.8. It's going to give you an exact answer of 14.95. So 14.95 seconds is when it splashes down. Now it says the rocket peaks at X meters above sea level. So you want to know what, so now when it actually asks for the peak, so they want to know on your graph, that's when it peaks at the high point. So we just need to use X equals negative B over 2A because that'll give us the exact height it peaked at. So we have negative of the B value, which in this instance is 52, divided by 2 times the A value, which is negative 4.9. So we need to find our X so we can find our high peak. So we need to find X and then plug that answer in to find the Y value component. So negative 52 divided by negative 9.8. The time frame it peaked at was at 5.31 seconds. They want to know what was the actual height. So we're going to take the 5.31 seconds and plug into the equation to find the exact height it peaked at. So we have, so our equation again, h of t equals negative 4.9 t squared plus 52t plus 318. Remember, we're using the 5.31 seconds. Negative 4.9 times 5.31 squared plus 52 times 5.31 plus 318. So you need to square the number first. So negative 4.9, and in parentheses we're going to do 5.1 squared is 28.2. 52 times the 5.31 is 276.12 plus 318. We're going to do our multiplication here. So negative 4.9 times 28.2 is negative 138.18. We already did the second part, which was positive 276.12, and then our additional 318. So we're just going to plug in this in the calculator. Negative 138.18 plus 276.12 plus 318. So we get a height of 455.94 feet for its peak value.